Hello everybody, this is Sahoo, Assistant Professor in Narasimha Engineering College. I'd like to welcome to all to my channel. Today, in this video, I'm going to discuss about one more sorting technique, that is insertion sort. Right? Sir, why this image is here? What is the work of this image? I will explain. Because the insertion sort mechanism, while we are playing the playing card, at that time we are doing. So it is a best example for the insertion sort. That's why this playing card picture is there. I will just remind you what exactly we are doing. I hope you people are playing the in your past or now itself. You are playing the playing cards. Okay, it's a very common games nowadays in the mobile also. Softwares are also available. We are playing that one also, right? Sir, what is exactly happening? Suppose the members of these games, they are sitting and the card has been distributed. Then immediately after getting the card, what the persons are doing, the member, what they are doing, they're they're starting to sort this card in the sense some people are starting. Suppose this is n, that means number one, they will make it try to take at this position before number two, they will make here, right? And similarly 2 4 8 is there, they are in proper order. Okay, no problem. Suppose 4 6 is there, and they will take suppose 4 to this last end. Some people based on their choice, their requirement, they are doing their trick, they are doing like this. So here what exactly we are doing, that is nothing but we are inserting a particular card based to a suitable position based on the requirement. Just before I show you the diagram like this, it's inserted before the 2, right? And after inserting 1 2 5 10, it is in proper order, right? So here the playing card is being sorted based on the requirement. By which technique? By taking any card, and this card is being inserted to a suitable positions. So this is nothing but the trick of insertion sorting. Suppose I have a number 30, 80, -4, 50, like these 25 numbers is there. So what I will do, I will take, suppose I want to sort it in ascending order. Ascending means small to big numbers. What I will do, I will select any number, suppose 80. I will select any numbers and I will search. And ascending order means from the left side, small number, then towards the right side, it will go to big numbers, right? Big number will come. Suppose 80 is a big number. 80 number I will check with this left side number. Is it required to insert in the place of 30? Not required, suppose. Then I will take -4. -4. Is it required to insert in place of 80? Yes, it is required because -4 is a less number. So it will be exchange here, swap here. 80 will come to this position and -4 will come to this position. Now work is not over. Again I will check this -4. Is it required to insert at the first position? That means position of that. Yes, it is required because -4 is the small number. Again, -4 will come to this position and 30 will come to this position. Sir, directly in the playing card, what we are doing, sir? I am taking the A and getting into two position before two positions. But actually in the program, the same thing I cannot do. Directly I cannot take a particular number before three number. Before this is 10, 5, 2 is there. Before directly I cannot take. What I will do first, I will check A with 10. Is it required to swap? Yes, it is required to swap. Then A will become here, 10 will become here. Then A with 5. Is it required to swap? Again, it is required to swap. Then A with 2. Is it required to swap? Yes, it is required to swap. So like this in the programmatic way I have to do. But playing card directly I will see, oh, A should be moved to this positions, I will move. But internally it should be compare A with 10 first, then A with 5 first, then A with 2 first. Okay, na? Here index wise sorting is not done. Index wise sorting is not done. Here element wise sorting is done. Element wise I will check the particular element to its corresponding left element near adjacent element. If the element is required to swap, then I will swap. But in the selection sort we are doing the index wise sorting, but here element wise sorting we have to do. Okay, so I will give you some more clarity on this. Observe here some diagram is there. So right now it is not being sorted. So what I will do, I will take this one first, this one. Okay, one. I will check this one with the left side element. Sir, is it required to swap? Yes, it is required to swap. A should move to this position and this J should move to this position, right? And what I will do, I will move these two to their corresponding positions, right? I'll move this one to this position and this one to this positions, right? Now it is done. Next I will select which one, this 10 I will select. Then I will check with this 10, is it required to move to J position and J is required to move to 10 position? Sir, yes, it is required to. Then what I will do, I will take this one and I will insert in the place of J positions, right? J positions, control V, I will insert here as 10. Then I will check once again here, is it required to move this 10 to A position and A to 10 positions? No, sir, not required. It is not required because A is the list number, 10 is the big number, right? Then what I will do, I will check this index. Okay, this index I will check. Sir, is it required to move this K to J position? Is it required to move? No, it is not required to move K to J positions, right? So it should be ignored. Then I will check this positions. Sir, is it required to move this Q to K position and K to Q position? Yes, it is required. Then do immediately. I will do this one. I will move this one to K position and K to this position, right? Q to K positions, right? Now by doing this, now see my array is being sorted. These elements, these playing cards is being sorted, right? The same technique also we are going to follow. So what is the technique? Every time I will select a number from the list. I will select a number from the list. Suppose list is 8 minus 4. This is suppose 25, and this one suppose once again suppose 13, and one more is minus 2 is there, right? I will check one element and I will compare with this left side element. I will take one element, I will compare with all its left side element. That means in case of 25, I will compare with minus 4, 8. If I take a 13 element, then I will compare with all the elements available in the left side. If I take minus 2, then I will compare all the elements available in the left side, right? This is the technique for insertion sort. By doing this, I can able to insert elements. Observe carefully. I'm going to explain the logic here. Suppose the elements are 8 minus 5, 23, 13 and minus 2. Okay. Now, sir, what is the index? Sir? Index important. 0, 1, 2, 3, 4. Here I told index wise I will not sort. I will sort element wise. Okay. But index is required here. Sir, I will take minus 5 first. Okay. 8. If I take 8 na, I always in the insertion sort I'm comparing with the left side, but to the left of it nothing is there. So I will take the -5, one index cell number. I will compare with this 8. Sir, -5 is less, 8 is big, so it is required to swap. Swap it immediately. -5, 8, 23 remaining as it is, you keep -2. Okay. Then after this -5 swapping, left side nothing is there. That means one attempt over here. First attempt over. First attempt done. Right. Then in the second attempt, what I will do, I will select one index cell element already selected. Now two index cell element I will select. What is there, sir? 23 is there. Sir, 23 I will compare with the 8. Is it required to swap? Sir, not required, right? If it not required, then remaining also here also not required to swap. So this one also not checked, right? As it is. In the second attempt, I will get same result, -5, 8, 23, 13, and -2, right? -2. Then two index work is over. Now three index work. Which one is there? 13 is there. I will check this 13 element. 13 with 23 I will check. Sir, is it required to swap? Yes, it is required to swap. So immediately swap in the third attempt I am doing right now. Third attempt. Right? Third, immediately swap. -5, 8, 13, 23 came here, -2 came here, right? Now after passing, after swapping, again my work is not over. Okay, now all they have to check this with all the left side element. Then 13, element 13 I have to check, not index number 13. I have to check with the 8. Is it required to swap? Is it required to swap? Sir, not required to swap. Again, -5 also it will be checked, not required to swap. It should be as it is in that current position, right? It is not required to swap. So in the third pass, I got this result. Now coming to fourth pass. In the fourth pass, what is the element? -5, 8, 13, 23, and -2. Now in the fourth pass, I will take the element which one? -2. Is it required to swap, sir? Yes, it is required to swap. Okay, na? So it become -5, 8, 13, -2, and 23. Then again check -2 with 13. Is it required to swap? Yes, sir. Again, it is required to swap because -2 is the less number. So result become in the fourth pass. It is continuing -8, 5, 8, -2 came here, 13 goes here, 23 goes here. Again, left side is more elements are there. Checking has to be continued. Then -2 will be checked with 8. So element wise checking, not index wise checking. Repeatedly, I'm telling my -2. So again, it is required to swap. Swap it immediately. -5, -2, 8, 13, 23. Okay, now after that one again check -2 with one more element is there to the left side. -2. Is it required? Yes, sir. 100% it is required. -2, -5, 8, 13, 23. Okay. Now see. Now this is my answer because after this -2, no element is there in the left side. So this is my final answer. Sir, how many attempts I have done? First attempt, second attempt, third attempt, fourth attempt. How many elements available? N equal to C, 5. Already I told in every sorting mechanism, if the number of element is n, the number of attempt you have to check n-1 time, right? So this is the logic. This is the step-by-step method I'm going to follow in the insertion sort. But how to write the program, how to write the logic, that is very, very important, right? Observe here carefully. I'm going to explain that things, right? That things I'm going to explain. Observe. 1 minute. These things I'm deleting, not required. Okay, not required. Right. This is insertion sort. Such same as it is. Take I equal I take J take. Right. Now first attempt when I equal to 0. I equal to 0. Right. This is also n value. N value. Okay, I'm taking it here. N equal to 5. Right. I equal to 0. So when I equal to 0, I will check this first cell index with this zero cell index. When checking is starting from one index, because zero index I cannot take, because zero index to left nothing is there. So checking has to be done from the first cell index. Sorry, one index. So one index means j will become one. Okay, j will become one. Now I will check with zero index. So j minus one I take. Sir, I value is zero na? Here. Actually, that concept will be not work here. It is here I value is reserved for number of attempt. First attempt, second attempt, third attempt. Checking will be done between j and j minus one. Checking will be done between j and j minus one. It is not just like the logic as a selection sort. It is just like the logic of bubble sort. In the bubble sort, j plus one. In the select insertion sort, j minus one. Because in the bubble sort, we are checking 0 with 1, 1 with 2, 2 with the right side. Here I am checking 1 with 0. Then in the next attempt, 2 with 1, 1 with 0. In the next attempt, 3 with 2, 2 with 1, 1 with 0. In the next attempt, 4 with 3, 3 with 2, 2 with 1, 1 with 0. Like this, I'm coming from right to left. In the bubble set, I'm going from left to right. Like this. So j minus 1. J minus 1 means it becomes 0. That means 1, 1, 0 index I will check here. What is the minus 5? 8. It is equal to swap, right? Now after that, after swapping, left side no element is there. So first attempt over. Now second attempt. Come second attempt. In the second attempt, I will become 1. If I will become 1, then j value, which one I will check? 23. Second index value. That is j will become 2. Okay, I will check with 2 with 1. Okay, now 2 with 1 I will check. Left side, left side. After checking, I will check with 1 with 0. That means 2 with 1 will be checked. And 1 with 0 will be checked here. Okay, 1 with 0 will be checked. After this checking 1 with 0, left side nothing is there. So stop. Second attempt over. Now coming to third attempt. Then third attempt I will become 2. I will be step by step, one by one, it will be increased. I will become 2 means now last time 2 index over, now 3 index. 3 index will be checked with 3 index, that means 13. 13 value will be checked with 2 index. Then 2 index will be checked with 1 index. Then 1 index will be checked with the 0 index. That means starting value 3 with 2, 2 with 1, and 1 with 0. Okay, na? So every pair I am writing. This is j value, this is j minus 1 value. This is j value, and this is j minus 1 value. This is j value, this is j minus 1 value, right? Okay, na? Now after third attempt, fourth attempt. Now after this one, nothing is there, so fourth attempt. Fourth attempt means four cell index, which are minus 2. Minus 2 will be checked with this elements. Then this again minus 2, this index checked with this index with this index, this index with this index. That means if fourth attempt I will become 3, j will become index value is 4 now, so it will become 4 with 3 will check left side, then 3 with 2 will be checked left side, then 2 with 1 will be checked, then 1 will be 0 will be checked. So like this logic is following in the insertion side. Now see how I am converting into program. For observe here, very important. So number of element 5. I value started from 0, end at 3. If number of element 5, it is ending at 3. What is the difference? 2 na? 5 minus 3, 2 na? So for I equal to starting value is 0, and I less than equal to n minus 2. N value is 5. Okay, na? N value is 5, and here I value ended at 3. So 5 minus 2, it becomes 3. If I don't give equal, then you have to write here 1. Okay. That means 4. Less than 4. Less than 4 means up to 3 it will be contained. 4 will be not considered. Okay. So as it is in the every selection sort, bubble sort also, same thing we have taken. Then I plus plus. Right. Now for loop over. Then 1 minute. Let me. Okay. Now for loop, first for loop over. Second for loop right here. For observe j equal. Now when I value 0, j value 1. When I value 2, j starting value 2. When I value 2, j starting value 3. When I value 3, j starting value 4. That means we will compare I value and j value. What is the relation, sir? J value always greater than 1 comparison to I value. So j value become I plus 1. Right? Because you have 0, this is 1 greater. When 1, this is 2, 1 greater. So this is when 2, this is 3, 1 greater. So y plus 1. Okay. Now see, starting value, ending value is what? Ending value is j, ending value is 0. That means it is reducing, it is not increasing. Starting value is 1, ending value is 0. Here also, starting value is 2, starting value is 2, j value, j value, j value, j value. Ending value is what? Ending value is what? Again 0. Ending value is 0. Okay. When starting value is 3, ending value is 0. When starting value is sorry, okay, starting value is ending value is 0. When starting value is 3, ending value is again 0. Actually, it is j minus 1. This is j value 1 here, here 1 here, here 1 here. That means every time it is ended at 1. So I can write j should be greater than 0, or I can write greater than equal to 1. Two things, either greater than 0 or greater than equal to 1, right? Like this also you can write, no problem. Then here j plus plus not, here j minus minus. Why? Because value reducing here. See, 1 to 0 coming, 2 to 1, 1 to 0 coming, reducing, 3 to 2, 2 to 1, 1 reducing, j minus minus. Don't write plus, don't write plus. Then same logic, right? If array name suppose a of j minus 1, okay na? J minus 1, a of j minus 1 is greater than a of j. Okay, a of j minus 1, which one? Left side. Suppose j is 1, j minus 1 is 0. That means 8 is greater than minus 5. Like that it is checking. If greater than, then swap, immediately swap. Swapping technique, temp equal to a of j minus 1, a of j minus 1 equal to a of j. Okay, then a of j equal to temp. By writing this logic, your array will be being sorted by using insertion sort. Then you have to print the element, right? Print the element. Now see, look at here, I will write the same logic what I explained here is working or not, we will see. Very simple. Okay, as include, 1 minute, why this one? Okay. Has include stdio.h, has include conio.h, void main. The same format in the every program we are facing this one. CLR is CR function. Now variable declaration, sir. First array declare integer a of 20, suppose. Okay. Now for loop array executions, I is required, j is required, and number of elements the user has to give. Here semicolon mistakenly given, comma. Number of elements the user has to be decide. For that n is required, one temporary variable is required, this many variable. In selection sort also this many variable, bubble sort also this many variable, insertion sort also this many variables, but writing methods is different, little bit changes only, very easy to remember. Okay, next, printf enter n value, how many elements you want, first you enter n value. After entering, then message display, immediately the user has to be entered from the keyboard, then scanf percentile d comma ampersand n, right? Next, after finalizing the n value, how many elements you want to enter to the array, immediately enter elements to the array. Printf enter percentile D elements to an array, right? Comma en. So what is your n value? That n value will be replaced with that percentile D. N value 5 means percentile D, in the place of percentile D 5 will come in the black screen. Enter 5 elements. So n value 6 means enter 6 element. Like this it will come. Okay. Immediately the user starts to enter those values input. But 5 elements means 5 times scanf function. Instead of that, for loop, right? Very interesting. I equal to 0, I less than n, I plus plus. Okay, 5 times or n number of times it will be repeat. Then scanf immediately use percentile d comma ampersand a of I. What is the array name? Just write. Same logic, how to input element to the array, how to display element from the array. This is the very old methods. In the previous classes we have discussed a lot of times, many in every examples, right? Now coming to this one. So elements entered happily. Next I have to write the sorting mechanism. Sir, what is the sorting mechanism? Very simple. For I equal to 0, I less than equal to n minus 2. Okay, na? Same logic. This for loop, this first for loop is same in selection sort, bubble sort, insertion sort. But the second for loop is changing in the every methods, right? But this first line for loop is same in every sorting mechanism, right? Selection sort, bubble sort, and insertion sort, right? I plus plus. Okay. Bracket start. For j equal to, I told what is the j value? Always greater than 1. So write I plus 1. Okay, na? And j ending value should be greater than 0. You can write, or you can write greater than equal to 1. You can write, sorry, greater than equal to 1. You can write two things. Anyone is fine. Okay, sir, I'm writing greater than 0. Okay. Then here don't write j plus plus, because we are checking from the element towards left side. I'm reducing the index, so minus here. Okay, a lot of times the students are doing a mistake here only, right? Now swap it. If condition, right? First, a of j minus 1 left side element is greater than a of j current element, then bracket start temp equal to a of j minus 1 and a of j minus 1 equal to a of j minus 1 equal to a of j and a of j equal to temp, right? Now logic over. Now if statement close, second for loop close, first for loop close. Now sorting is done. Now the time to print the sorted elements. Give message, puts sorted elements are right. Sorted elements are like this. Keep. Sir, how sorted element, number of elements are there now? So how to print the elements from the array? For loop, by using for loop or in number of time printf function. That is not recommended at all. So for loop I equal to 0, I less than n, I plus plus. You can take j also, no problem. J equal to 0, j less than n, j plus plus, I plus plus. Anything you can take, right? Not a compulsory restriction is there. Printf percentile 4d. For more gap I'm taking, because minus sign, if I'll give minus number negative, that sign also considered. Percentile 4d a of I. Now see, program over. For loop, this for loop bracket no need to be required, was one statement only, so curly bracket I ignored here. Get ch function and closed, right? Alt F9. Sir, any error? No error, right? Error free program, control F9. What is asking, sir? What is asking? Enter n value. I'm entering 5. Okay. Enter 5 element to one array. Immediately you have to enter the 5 elements, sir. So what is the element we have taken? 8 minus 5, 23. Next is suppose 34. Okay, 34. Okay, one more 13 13. Okay, minus 2. Now see, after sorting, the elements become what? Minus 5, minus 2, 8, 13, 23. Ascending order? Not, sir. Descending order. For descending order, how to put descending order? Simple. Descending order means big to small number. Na? Only one changes you have to do here. This one. Greater than is there, put it less than. Greater than is there, put it less than. Nothing has to change. Only here you have to change. Observe all definite. Let me save this program first, because if any problem will be happen, once again I have to write. Save as this is insertion sort, right? Now observe control F9. Any error? No error. 5. This is descending order. From the beginning I'm telling. Now 8, same number, minus 5, 23, 13, okay, minus 2. See, printed or not? First 23, then 13, 8, minus 2, minus 5. Only one sign I changed. Program totally reversed the result, right? So this is the technique for insertion sort. I hope it is very, very clear to all of you. If not so, at least watch this video 1, 2 times, 3 times, then you will be very much clear, right? I hope you will be fine. And in the remaining topics, remaining chapters, important chapters, we will discuss in the next video. So till then, you take care and bye.